number. This will be done when all the values are equally important. When all the values in the data is equally important, we will take arithmetical mean. Okay?
Okay, ma'am.
Understanding?
Yes, ma'am.
And we have something called growth mean, which is geometrical mean, which is which I, for example, I will take, if I say, for example, I'll say, my company has done in year 1 10% of profit, year 2 20% of profit, year 3 30% of profit, 40% of profit, so and so forth. So over the year of time, year of period, or year over the sometime, there is some growth in my company, right?
Yes, ma'am.
So if I say, for example, I will take this here. So I will say, for example, I have company which has 10% of increment. So this is only profit I'm taking. Okay. 10% of profit. Then I have 20% of profit. Okay, I have 30% of profit in year 1 and year 2 and year 3. Okay, there is changes in the with the time, right? With the time, there is a change in my profits, right?
Yes, ma'am.
So here there is, because there is a changes in the, according to the time, there is a changes. So I will take the growth mean or the geometrical mean. How do we calculate that? There is a different formula for it. That is all the values into multiply product of all the values, power of 1 by n. N is number of things. Getting my point?
Yes, ma'am.
For example, I have taken here, in the year 1, there is 10% of increment. In the year 2, there is 20% of increment. In the year 3, there is 15% of increment. Okay. So as this is in the percentage, I'm converting it. Okay. How do I write 10% in the values? How will I write 10%?
0.10.
0.10. When you're doing growth mean, when you're taking out growth mean, you will add 1 to this, so that it will be easy for your calculation. Okay.
Y plus 1, ma'am.
So it is easy for the calculation. I'll tell you why it is important. Okay. When you go further, I'll tell you how it is converted.
Okay, ma'am.
Okay. When I add 1 to it, how much would be the value? 1.10, right?
Yes, ma'am.
So year 1 will be 1.10. So if I say year 2 is 20%. Okay, how do I write 20%? 0.20, right? Then I add 1 to it, so it is 1.20. Okay, so and so forth. Again, year 3 is 15%, so it is 0.5 plus 1, 1.15, right? So I will do multiplication of all these 3. Can you calculate this value? Can you give me the calculated value? Only for this. So I will open the calculator over here.
$1.518, ma'am.
10 into 1.2 into 1.15. Right?
Yes, ma'am. 1.518.
18. Okay. Then 1 point, so I'll write it 1.15,
No, ma'am.
1.51,
8.
518, 518, and to the power of 1 by 3. So if it is 1 by 3, I can write it as 0.333. So calculate this.
Ma'am, should I do multiplication, ma'am?
No, power. Exponential. To the power of. Point 333. Okay, it will be somewhere around 1.14.
519.
No, power, I'm telling. Power of 0.333. 1.18 power of 0.333. So if I say the calculator over here, there is no power symbol in
In scientific calculator only I did, ma'am.
1 second, I will show you. There is no power in this.
Exponentially.
Exponential is there. Okay. 1.518 exponential to, not exponential.
E.
This is,
Ma'am.
no, it is taking square. It is not taking that. It is taking square. I'm telling power of. It is not there. Check in your phone. In my phone, I'm getting it. Power is here. Wait. No, this is not the thing. When I did it my phone, it is coming correctly. Check.
No, ma'am. In my phone it's.
I will give you the screenshot of my phone. Okay, 1 minute. I'll send it to you personally because I don't want Akash also to get confused.
Okay, ma'am.
So I'll send it to you personally. 1 minute. See?
Right, ma'am. Got it, ma'am.
Let me. Okay. So here you get 1.147, something like that. Okay. So because we have added 1 here, so I will do minus 1. Okay, minus 1 when I do, what is the value I have? Is 0.147. Okay, if I converted it into percentage, it is 14.7%, right?
Yes, ma'am.
So this is the geometrical mean. So that's why we add over 1 over here. So it is easy for us to calculate. Calculation will become very smooth only when it is percentage over here. Only when it is percentage, we are adding 1. But when it is a normal, for example, over here, I'll show you one screenshot. This is for weighted mean. 1 minute, I'll stop sharing my screen. 1 second. So over here also, this again, there are 3 values, that is 4 tons, 9 tons, and 16 tons respectively over a year. So the geometrical mean of the yards. So what, instead of we can write 4 into 9 into 16. Okay. If I calculate the geometrical mean, then I can do power of 1 by 3 as well. The cube root also I can take. 1 by 3 can be written as cube root of 4 into 9 into 16. It is the same formula. Don't get confused because of this. Okay?
Okay, ma'am.
Understanding?
Yes, ma'am.
Don't get confused because of this. 1 by 3 can also be written as cube root. Okay. If it is 1 by 4, I have to take here 4 root.
Okay,
So
ma'am.
which is more easier is this one. So that's the reason I taught you that step. Okay. So here, so it is almost 8.2 tons when we calculate it. So when only with the percentage we will do this conversion.
Okay, ma'am.
Okay. Understood the growth mean?
Yes, ma'am.
Okay. Then we have one more mean. For example, sorry. We have one more mean. I will take up that as well. This is growth mean. And then we have something called weighted mean as well. What is weighted mean? Weighted, for example, each value contains a weight to it or a value to it. For example, I'll say I'm doing something called for example, your final result will you have 2 major exams and 1 major exam. So 2 major exams will carry 2 minor exams will carry 25 percentage of your marks, and the last final weightage will be 55%. The total will be calculated like this. Okay, understanding my point?
Yes, ma'am.
At that time, we will use weighted mean to calculate their middle value. Okay. So at that time, we use weighted mean. So over here maths will carry 3 weightage. So English will carry 2 weightage and science will carry 1. So how it is calculated is 90 into 3, that is marks into weight, marks into weight, marks into weight divided by weight mean. Understanding?
Yes, ma'am.
Divided by weight mean. That will give me the mean of this value. Getting my point? This is called weighted mean, usually applied in calculating some weighted data. For example, if I take an example of your marks only, CGPI or GPA, all that time you have to use weighted mean. understanding? These are the three different types of mean which we can see in statistics. This is the way of calculating the middle value when you have different types of data, right?
Yes, ma'am.
The different types of data, when all the value has equal importance, then we will calculate arithmetical mean. When the value represent growth or changing rate, then we use growth or geometrical mean. When some values carries more important than others, then we use weighted mean. These are the different types of mean which you can see. Okay.
Okay, ma'am.
Depending on your data set, use the different types of mean or median mode according to your data. Okay. Anyways, I will send you this. Where are you? I will send you this PowerPoint presentation. You can have a look. Okay. If you have any doubts, please let me know. Okay. Now, this is how you calculate, or you will see. So the different types of calculating the central value is using uh, mean, median, mode, or you can, according to your data, you have to see for weighted mean and growth mean as well, or you can use percentile to calculate the central tendency of the data, right?
Yes, ma'am.
Now, to understand how it is different, how the value is dispersed in my data, I will see a measure of dispersion that can be calculated using range, variance, and standard deviation. These are the three different measures which you can understand how the data is differed in my data set: range, variance, and standard deviation. Okay. Sorry. So how do we over here, how do we calculate range? Range is calculated maximum value minus minimum value. So here in this, if example, this is the data set. So maximum value is 50 and minimum value is 10. Uh, the difference between these two will give you the range of the data. Okay, so if there is a large difference, for example, over here, if it is 100 minus 10, so that would be 90, right? Now, right?
Yes, ma'am.
So this is a lot of difference from my values, because of there is one maximum value. My data set is my range is completed. So when there is a large range, there is more variation in the data, which says more variation in my data. When there is a small range, then there is more what say all the data is interconnected, right? I can say that, right?
Yes, ma'am.
So for example, over here, if there is, so the maximum value is 40. So 40 minus 10. So this will be very less difference, right? 30, which is already in my data set, which is all interconnected. I can say everything is interconnected in my data. When there was 100, there was 90 was my range, right? There was more variation in my data, right? To understand more deeper, we will calculate variance. So more than variance, standard deviation will tell you more information, but we need to know, because standard deviation is nothing but square root of variance. Okay, standard deviation is nothing but square root of variance. So that's the reason we will understand what is variance first. Understood?
Yes, ma'am.
So we have a formula. Variance is represented with this symbol. Is so how do we calculate it? Is, for example, this is my data and the mean of this, the arithmetical mean of the data is 5. So we will take each and every values. 2 minus 5 square, 4 minus 5 square, 6 minus 5 square, 8 minus 5 square divided by number of the values. Okay?
Yes, ma'am.
Divided by number of values, and the variance will become 5. Variance is represented in new square. Okay, I don't have the symbol over here. So new square is represented in the variance. Okay, variance is represented as new square. Okay, then we will take, to understand more about the data, standard deviation is taken. Mu is written as square root of variance. Again, 5 square root is 2.24. Right?
Yes, ma'am.
What is the mean of the data? Was 5. Right? So here, what does it say is, so small standard deviation will tell you values closer to the mean. All the values are closer to the mean. So yes, I can say over here, all the values are little closer to the mean. When there is a large standard deviation, it is all the values are far from the mean. That means it is very far from the mean. For example, if I say, I'll give you more example on this, then only you will understand. Okay, I'll give you a few questions after this class. You can understand it more. Understand what is standard deviation now.
Yes, ma'am.
The variance also understood. I will tell you sample and population difference tomorrow. Okay, more details. I will give you more pictures and all, because it is very so if there is a, for example, I'll say this is the population. If I say this, the huge table is the population. So this is the whole population. For example, this is, imagine this is the whole population. Okay, I will divide it into multiple groups. Okay, imagine, see my cursor. Okay, imagine I'm dividing this whole population into multiple groups. Each group will become a sample. Understanding what is population and what is sample?
Yes, ma'am.
So if sample is a part of the population, okay, if I say this is the whole population, each population can be divided into multiple sets, and that sample of the data, if there is thousands of data, if there is 1,000 number of data, I can take only 5% of it or 2% of it, that will become my sample data. Getting my point?
Yes, ma'am.
Okay, that will become more useful. Sample data will become more useful when you have tremendous amount of data. When you have thousands amount of data, then you will take sample of the data and then try to understand each sample.